I was originally going to make this video sometime in the future after finishing my blockchain series, but that didn't work out. As it turns out, I needed this explanation as a basis to explain blockchains more easily. Just as a note, this is not a technical explanation. That will come in the next video on hashing that I plan to make for those who are interested. Like blockchains, hashing is very commonly misunderstood. So the first thing I want to do is set the most prevalent misconception straight. Hashing is definitely not the same thing as encryption, as many people seem to state. Now, some of the confusion may come from the fact that both hashing and encryption belong to the same field of computer science called cryptography. However, I repeat, hashing is not the same as encryption. Oh, and it has nothing to do with this, or this. The simplest explanation of what hashing does is that it is a process that takes in a piece of data as an input and produces another piece of data as an output. This output is called a hash, and it is always the same size, no matter the size of the input. The output is determined by an algorithm called a hash function. So the main purpose of a hash function is to generate a repeatable and unique value with a constant size based on its input. But it is not just used in blockchains like I alluded to before. They are also used for generalized detection of data modification, as well as in some search algorithms, and are a key part of making the process of password login safe and secure. There are some key points I want to make about hashing and hashes. First up, for a given input, a hash function will always produce the same hash. Some common hash functions you may have heard of are MD5 and SHA-256. In general, different functions will produce different hashes from the same input. These hashes can differ both in length and the content of the hash. Another key behavior of hash functions is that for two different inputs, even if they are very slightly different, the two hashes are almost certainly very different. For example, let's take the aforementioned MD5 hash function and hash two highly original but only slightly different sentences. As you can see from these hashes, from these two inputs, despite the fact that the two inputs only differ by one character, the hashes are very different. And just to demonstrate the previous point about the differences in the hashes from different hash functions, here are the same sentences hashed with the SHA-256 function. One last point I want to make about hashing is that it is nearly impossible to reverse the hashing process. By that I mean you can't take a hash and work out what was used to generate that hash, at least not easily. In general, the only feasible way to do this is by brute force, and trying every possible input and comparing the output to the hash you have at the beginning. But this can take a very long time, often a practically infinite amount of time, and even if you find an input that creates a matching hash output, it is still not guaranteed to be the original input, as it's definitely possible for two inputs to have the same hash, and this is known as a collision. So that just about covers the bare minimum about hashing, so you can either move on and watch part 2 when it's available, or the blockchain series if it's available by now. Thanks for watching.